AB Calculus Note Card 24, Implicit Differentiation. This is video lesson number 24, inspired by Stacy McMullen, formerly of the Dallas Independent School District, who I was trained with for 2 summer sessions, as well as trained by her co-worker Tracy Etheridge for 2 years. And an implicit differentiation problem will look kind of like this equation here, where you have variables all mixed up. You just don't have a single variable on one side of an equation. And we're going to use these principles here to find dy dx for an implicitly defined relation, differentiate both sides with respect to x, collect dy dx terms on one side and all the other terms on the other side, factor out dy dx, again on one side of the equation, and then solve for dy dx. And these next 3 problems are going to be applications of implicit differentiation. And so here we have the first one. Find dy dx for y to the 4th power plus x cubed y to the 5th power minus 2x to the 7th power equals 13. And we will implicitly differentiate one of these terms at a time. And so what is the derivative of y to the 4th power? Well, it's going to be 4 y to the 3rd power. And if we differentiate with respect to x, we're going to have dy dx. And then we have x cubed y to the 5th power, and this is going to be a product of a u variable and a y variable monomial. So what we're going to have is, we're going to have the original here, x to the 3rd power times the derivative of y to the 5th power. And derivative of y to the 5th power with respect to x is going to be 5y to the 4th power, and then we're going to have dy dx. And next we're going to take, using the product rule, y to the 5th power times the derivative of x to the 3rd power, which is 3x squared, and we're going to have dx dx. Okay, we're taking the derivative with respect to x. We have dx over dx minus 7 times 2 is 14, x to the 6th power, and that'll be with respect to x dx dx. And on the right side of the equation we have 13, which being a constant is 0. So now I'm just going to simplify these terms here on the left side. And so we have first 4y cubed dy dx. And then we have this 5 here. So I'm going to bring this 5 out front. So we're going to have 5x cubed y to the 4th. And that's going to be dy dx also. And then we have this 3 over here. So this 3 we're going to bring out front. So we're going to have 3. And I'm going to put the x squared first. 3x squared y to the 5th. And next, this dx over dx will cancel each other. So I'm not going to put anything else here with this term. Then we're going to have minus 14 x to the 6th power. And then we have dx over dx, that cancels, and we have 0 on the right side. So we've implicitly differentiated. Now we're going to take everything without a dy dx and move it over to the other side of the equal sign, which we're going to do by subtracting 3x squared y to the 5th. So on the right side we put minus 3x squared y to the 5th power. And also we're going to add this 14x to the 6th power to both sides. And so these 2 terms will cancel each other. So now I'm going to just try to save some time by factoring. Our common factor here is going to be this dy dx. So you have dy dx times quantity. You have 4 y to the 3rd power, and then we're going to have plus 5 x to the third power, y to the fourth power, and that's all that factored out. And on the right side of the equation, we're going to have 14x to the sixth power minus 3x squared y to the fifth power. And now, to solve for dy dx, we need to divide both sides of this equation by 4y to the third power plus 5x cubed y to the fourth power. And doing the same thing on the right side, we have divided by 4 y to the third power plus 5x to the third power y to the fourth power. And then we cancel that, and we have left dy dx is equal to 14x to the sixth power minus 3x squared y to the fifth power over 4y to the third power, it's supposed to be third power, plus 5x to the third power, y to the fourth power. So there that is. Implicit differentiation example. Next example we're going to look at is 2. Find the line of tangency in normal line to the curve of this equation here, x squared minus xy plus y squared equals 7. And we're given a point here. Sometimes you're not given a point. Sometimes you're given an x value, and then you have to use the original equation to find the y value, but we're given the point here. So again, implicitly differentiating, the derivative of x squared is going to be 2x, and we have dx dx. And then we have a product rule situation similar to problem 1. So we're going to have minus x times the derivative of y, which is dy dx, minus y times the derivative of x, which is going to be, with respect to x, dx dx. And then we have plus the derivative of y squared, which is 2y dy dx. And on the right side of the equation, we have the derivative of 7, which is 0. And now we're going to take everything without dy dx, and we see where we cancel dx over dx, dx over dx. And so we're going to subtract 2x, and we're going to add y. Okay, so we have subtract 2x, add y, and they cancel each other. And so we're left with negative x dy dx plus 2y dy dx is equal to y minus 2x. So next, factoring out the dy dx, we have dy dx times this 2y and also minus x, and is equal to y minus 2x. And now finally solving, if we divide both sides of the equation by 2y minus x, we have those cancel, so we have dy dx is equal to y minus 2x over 2y minus. So anyway, that's what we have. That is our dy dx. It says the point of line of tangency. So we want to find dy dx where x equals 1 and y equals 2. So I'm going to say dy dx at negative 1 comma 2 is equal to, we just substitute in here, so we have x squared, we're going to go into, actually this one down here, y, so y is 2 minus 2 times, we have x is negative 1 over, we have 2y, and y is 2, and we have minus x, which is minus negative 1. So that's going to be equal to 2 minus 2 times negative 1 is going to be 2 plus 2, or 4, over 2 minus negative 1. That's going to be 4, because that's going to be 2 times 2 is 4. That's going to be 4/5. So what that's going to be is our slope of the line of tangent line. So I'm going to call it m sub t. Okay? And then for the slope of the normal line, it's going to be a negative reciprocal. So I will say m sub n, which is slope of the normal line, is going to be negative 5/4. And now we can solve the equation. And this is a big type equation in calculus, the point slope form, which is y minus y1 equals m times quantity x minus x1. And we're going to use both of these. So here's for the tangent here on the left. I'm going to work below. We're going to have y minus y1, which is 2, equals the slope of the tangent line, which is 4/5. We're going to have x minus negative 1, and x minus negative 1 is x plus 1. So this is our tangent line. And then our normal line is going to be the same thing here, except y minus 2, that's the same, equals, we're going to have negative 5/4 times quantity x plus 1. So that's going to be our normal line. Okay, at that point of tangency. 3, find the instantaneous rate of change at 1, 1 for x plus 3xy minus 2y squared equals 2. I recommend you can just stop the video and work this out, see if you get the same thing I do later. Okay, implicit differentiating, the derivative of x is going to be 1, and it's going to be dx dx. And then we have plus 3, let's say 3x times the derivative of y, which is going to be dy dx, plus 3y times the derivative of x, which is dx dx, dx over dx. And then we have minus the derivative of 2y squared, which is going to be 4y, and times dy dx. And on the right side of the equation, the derivative of 2 or of any constant is 0. And so anything with dx over dx, we'll just cross out the dx over dx, and then we're going to subtract that out from the left side. So minus 1 minus 3y, and then on the right side, minus 1 minus 3y. And so these cancel here. So we have 3x. And I'm just going to factor out here. So we have 3x dy dx. So we're going to have dy dx times 3x plus, that's going to be, this could be what? Minus, plus minus 4y. is equal to negative 1 minus 3y. And next we're going to divide by 3x minus 4y. Okay, good. So we cancel here. So dy dx is equal to negative 1 minus 3y over 3x minus 4y. And then finally, dy dx for this point here, 1, 1, 1, is equal to negative 1 minus 3 times 1 over 3 times 1 minus 4 times 1. And that's going to be equal to negative 1 minus 3 is negative 4 over 3 minus 4 is negative 1. And so we conclude, I'm going to work to the right here, dy dx at 1, 1 is equal to 4. So that will be our answer. I put dx here on the left. It should be dy dx. So those are a few example problems. I hope this is helpful to you. Good luck, and thanks for viewing.